This shop stool project came about because our director, who has a slight weight problem, was sitting in my old shop stool and collapsed it. So I decided to go about designing a shop stool that would be both attractive and functional. We've selected white oak and dyed it a darker brown to give it a little bit more character. We've incorporated a swiveling top that's nice and heavy duty. It's at the appropriate height for working at a workbench. And all around, it's a fairly simple project to build. The joinery is quite straightforward. So take a look, and we hope you have fun building it. Now I'll be making my stool out of white oak. Now I happen to have a lot of highly figured white oak, and unfortunately it warped and twisted up on me here in the shop before I had a chance to use it. That just happens sometimes with highly figured woods. But in any case, I'm working with 3/4 inch thick stock, and most of our pieces are 1 inch and 1.25 inches thick. So what I'm going to do is laminate two pieces together to get the overall thickness that I want. Now when it comes to the seat, we need that to be almost 1.5 inches thick. So what we're going to do there is glue up the pieces just as we are with all the other components. Now of course you can go out and purchase the thicker stock and avoid this step altogether. But when face joining, or when gluing two pieces of wood together face to face like this, you do have to have a nice, smooth, flat surface. And really one of the best tools in the shop to start with to get that surface good and flat is over here at the joiner. So we'll go ahead and join each of our faces so that we've got a nice, smooth, flat surface. Now there's a couple approaches we can take for gluing up the pieces that make up the seat. Because the seat is so wide, I need to make it out of 3 pieces to get the overall width, keeping in mind that it will be a circle when we're done. Now I could go through and glue up 3 pieces like so, edge joining them of course, glue them together, and then I'd have my one panel, do the same for the other 3 pieces, and have my second panel. Then I can laminate those 2 pieces together. That can be a bit of a problem in some cases because now your panel's too wide to pass it through the planer or even to face join it at the joiner. So what I'm going to do is just work off of the narrower pieces like so. I'll glue up each board face to face, get my 3 blanks up to their thickness, then I'll edge join them and then bring all 3 pieces together to create the larger piece. So our next step is to apply glue and clamp these up real good. Then we'll spread it out to get a nice even film, and that should do it. We'll let the glue set up for about an hour before moving on with the seat. Now these 2 will be our leg blanks. This is going to be the spider, and I've already glued these together. Now I did go through and face plane this surface where we join the 2 boards together. Now what we need to do is face plane the outer surface, plane it to thickness, and joint one edge. So we'll start back over at the joiner to finish preparing our stock. Now we can go over to the thickness planer and we'll pass it through there, of course with our qualified surface down against the table surface. Then it's back over to the jointer to put an edge on there that's square to the faces. Then it's over the table saw to square up the other edge. Now because of the blanks that I'm using were wide enough where I'm getting 2 legs out of each blank, I had to do a layout line to create my 2 individual leg blanks, and it turns out it's a tapered cut, so the bandsaw was an easy choice to separate my 2 leg blanks from the overall stock. Now we can go ahead and cut the legs off to their overall length. Now the angle works out to 7.9 degrees, so almost 8 degrees, so I'll set my miter saw at that angle. I'll qualify or take a qualifying cut on one end and then cut off the other end to make up for the overall length. Now the overall length of the leg on the drawing is given from the long point to the long point. So what I'm doing is I'm just measured off of my long point down to this end, and then this would be the long point on the opposite edge where we need to cut our overall length off to. Now what we need to do is lay out that curve that's on the outside edge of each of the 4 legs. Now on the drawing we'll give you the dimensions for the width at the top and bottom, and then 6 inches up from the bottom another width. So that'll give us 3 points, and we want to create a curve between those 3 points. A bow is really about the best tool to do this with. Now normally I use a string to draw tension on that bow to create the curve. However, because this is a rather thick bow and because it's such a shallow curve, it's hard to get the string adjusted just right. So what I do then is I take a long bar clamp and squeeze together that bow to create the curve. And then I'll place my work under it and slide it around until I see my 3 layout marks. And if I need to, I can always adjust the curvature by creating more clamping pressure or releasing the clamping pressure to create less of a curve. Once I get something that looks about right, we'll just pencil it in, go over to the bandsaw, and trim it up. Clean up the surface that we just cut on the bandsaw. The oscillating spindle sander makes quick work of that. Our next step is to route the grooves along the spider and on the legs, on the inside edge of the legs, to accept our webbing. And that, of course, is our bracing for the legs. Now, to machine those grooves, I'm using a 1/4 inch diameter white side router bit, and I've currently got it set a 1/4 inch up from the table surface and a 1/2 inch away from the fence. Now, because this will be a stop cut on our legs, we're going to be affixing a stop at the end of our cut. Now we need that stop to be 14 3/8 of an inch to the far side of the router bit, so we'll just slide it down and clamp it in place. Now on the legs, as I mentioned, this is a stop cut, so I'll feed in all the way up to our stop, and then I have a knee switch on my router table, which makes it very easy to turn off the power so that I can safely remove the workpiece after the router bit comes to a complete stop. And at this point, we're pretty well done with most of the machining on our legs and on the spider. Now we can turn our attention to the web braces. For the leg braces, I'm going to be making mine out of 1/4 inch thick hardboard. It goes under the trade name of Masonite, and the type that I've chosen is the smooth. It's smooth on both faces. It does take stain very well, and because I want them to be black, I'm not really concerned about grain or anything of that nature. Now if you want, you could of course use 1/4 inch plywood. Now I'm going through the process right now of doing my layout, and it's very, very simple with all the basic tools. Just lay out your points and basically connect the dots. And to help with layout, sometimes even the most unusual inanimate objects, such as a garbage can lid, works out for the perfect radius. And when creating these small blended radii in the corners, a drafting circle template is a wonderful tool. We'll just line it up. We want a 1/2 inch diameter circle in there, 1/4 inch radius. So I'll just line up the edges of that circle with our lines, pencil in the radius, and then they provide these handy little quadrant marks. Make those, draw a square across that, and now I know exactly where to drill with my 1/2 inch Forstner bit. Now when I did this layout, this corner here was a true right angle. This line, of course, follows our almost 8-degree taper, and then we've got our radius down here. So we don't want to do anything in this area, and we do want to be very careful cutting that long straight edge. Using a 1/2 inch Forstner bit in the drill press, we can quickly drill out the 4 corner holes. And using either a jigsaw or scroll saw, you can finish up cutting out the inside shape. And some final touch up here at the oscillating spindle sander. And a little more touch up with some files and sandpaper to make everything blend nicely. And now we can use our first one we made as a template to draw out the remaining 3 and cut those and shape them the same way. And as you can see, I'm going through now and fitting up all the pieces. And if you remember, we made that stop cut with the router. Now what we'll do is we'll make a small mark and square up that end with a bench chisel. I'll start out with a 1 inch chisel and work the sides up to our cutoff point. Just go on a little ways. Now we'll take a 1/4 inch chisel and break out the end. Well, everything's fitting together good and it's starting to look like our stool. Now our next area of focus is to get this top plate on here, and that will of course tie together the 4 legs at the top portion, provide us with a platform to mount up the swivel, and then we'll work on the seat a little bit later. Now we'll also be working on the hoop that joins together the 4 legs at the bottom, and that hoop also serves the purpose as a footrest. So let's get this piece out of the way and then we can move on. To make the frame top, I'm working with 3/4 inch birch plywood, and I've squared it up a little bit. I'm not overly concerned about it, but what I do need is one edge to be nice and square or straight, and then off of that edge I'm going to measure for my pivot pin, because we're going to be using a jig over at the bandsaw, and that requires a 1/4 inch hole for the pivot point and it to be located exactly whatever our radius is from the edge. So we'll get that hole drilled. Now our plywood piece with the hole in it is going to pivot on this pin. And this is an attachment from Delta, the manufacturer of this particular bandsaw. Works out that we want a 12 1/4 inch diameter piece when we're done, so we need our offset, or the distance from the center of the pivot to this edge of the saw blade, to be 6 1/8. And that'll be our frame top. Now as you can see, we've got the plywood edge here to deal with, so we're just going to run a band around there of this white oak. And we'll just tape that up and glue it up best we can. Now you may be wondering, why not just make this component out of solid wood? We possibly could because of the size of this, but we've got essentially a cross-grain situation here. The frame itself isn't going to come and go with the seasonal changes, nor will plywood. But if we make a solid wood frame top that's securely attached to the legs, the top is going to want to come and go, the frame isn't. So they're always going to be fighting each other, and eventually it'll just break apart. So really the best solution is plywood, and then we'll edge band it. So we'll cut up some edge banding over at the table saw, and then we can get that step out of the way. Now the edge banding that I want to make is going to be about a 1/16 of an inch thick. And to try and rip a 1/16 inch thick piece of material tight against the fence is just asking for trouble. It's too hard to control that small of a piece. So when I'm down that narrow, I like to keep the offcut piece. So what I'm going to do is pass the large part of the board through between the fence and the saw blade, and then the offcut will be my keeper piece. Now I don't have to worry about it being exact thickness. It could be a 1/16, it could be 3/32. It's not going to affect us. So I've already passed this board through once, so I've qualified its width. Now all I need to do is shift over my saw blade kerf plus a 1/16 to get a 1/16 inch wide strip. We'll first start out by wrapping it around dry to make sure that it is in fact long enough, and we are. Now what we'll be doing is gluing it around the edge. And I'll be using liquid hide glue, which is a very strong glue, has a real good open time to give me time to fiddle around with positioning it and so forth. Don't like to rush. And we'll just work our way around, pulling it, taping it, pulling it, and taping it until we get all the way back to the starting point. Now at this point I've got it wrapped all the way around and overlapping where we started from. Now I want this to be a fairly tight joint, so I'm going to use a thin razor saw and cut through the 2 pieces right in this area. Get this piece out of the way. I can see I got a little touch-up to do in there. Take a utility knife, clean off that little burr. And we'll finish it up with a band clamp to help force that together good and tight. Now we can turn our attention to the hoop. And that hoop, we want the center of it to be right at the end where our webs terminate. So that hoop should be right about here. So what we're going to do is measure about 3/8 of an inch up, get a rough idea what that's going to look like, and then we're going to measure across the two legs from side to side. And as you can see here, I've got about 14 inches and 7/16. That's going to be the inside diameter of our hoop. Now what we need to do is make that mandrel. Now on the drawing, we're going to be showing that dimension, but depending on how you did your curves, that could vary quite a bit. So I highly recommend you take this measurement before making the mandrel. Now here's the mandrel that I've cut. Cut it the same way I did with the other pieces over at the bandsaw using the circle cutting jig. Of course, you could always use a jigsaw. Then I just created an opening in the center. It's about 8 inches in diameter, and that allows us to clamp our strips as we build this hoop. Now keep in mind, we don't want to attach our strips of wood to the actual mandrels, so be careful there. You don't want to apply glue around this and glue your hoop onto it, because it's going to be rather difficult to get off. And in this case, we're working with a slightly larger diameter, so instead of a 1/16 inch thick edge banding, I'm going to go with 1/8 inch thick strips. Now when we go to wrap our strips around our mandrel, we don't want to have a gap where that starting point is. As you can see here, I've got one piece overlaid on top of the other, and we've got this terrible gap there. Now the only way to really get around that is to grind or sand a long taper onto the end of our first strip. So we'll go over to the belt sander and do that. Now here at the belt sander, you can see I'm holding my thin strip against the belt, and I've got a backer board to help apply even pressure so I get a nice even taper as we sand away the material. Now let's see how that'll work. We'll have our thin tapered area and then our next strip coming out, and that blends in real nice. So that'll work out fine. Now as you can imagine, this is going to take some time to glue up this hoop. We're going to start out getting our first band all the way around and then overlapping it however far we can. And then that overlap area is the only place you're going to apply glue. There will be no glue against the mandrel. And then we'll clamp that up, let that one dry, and then we'll continue on piece by piece as we add these strips in. Now the ends of all my strips I've cut square so that when they bump together at our joints, we'll have a pretty decent fit there. Now I'll start out by clamping my first strip in about 6 inches from the end. We don't want to try to clamp and hold it just on this real thin section because it's just going to break away. So we'll clamp that in, and then we'll carefully bring this around. Now keep in mind, my strips are 1/8 of an inch thick, and as you can see, it's a little bit of a struggle to try and keep that tight against the mandrel. Now as we get all the way back over to where we started from, we'll put a clamp on there temporarily. Now if you find that your oak is splitting or not cooperating, there's nothing wrong with soaking it in water. Hot water or warm water will soften it up so that it's a little bit more pliable. Or the other alternative is cut thinner strips. Now what I'm going to do is apply glue in our overlap area. In this case, I'm just using yellow wood glue. You could of course use hide glue. That might work out a little bit better, but the clamp time and drying time is much longer. And we'll put this clamp right at the start of our overlap. And a third hand would be real helpful, but gotta do what you gotta do. Now what we can do is move this clamp over, apply glue under this area, and clamp in the tail. Now as you work around, you'll do your best to make sure that you keep all of your individual plies lined up so that they're all flat against your work surface. Now just add as many clamps as you can to get in there. Let it sit and dry, and then we'll add the next band and the next one and so forth. And as I mentioned before, we just keep working our way around. Apply glue, apply a band, clamp it up really good, and clamp it up as far around as you can go. Sometimes you can't end at an end point, so you'll have to leave a tail hanging off. But just force some glue down into that joint, continue the clamping operation as it allows you to. Well, this is our stool seat. As you can see, I finished up the glue up process, sanded the faces somewhat smooth. I then took it on the circle cutting jig at the bandsaw to get it round. Now, if you have a lathe that can swing 14 inches, you can mount this up on a faceplate and put your radii on it, so forth, and put a little contour into the center area. But if you don't, we'll show you some steps using a handheld router and a grinder so we can shape up the seat a little bit to make it more comfortable. Now we're going to start out on this bottom edge to put a 1/4 inch round over on it. Once we get that one done, we'll switch over to a 1-inch radius round over bit and round over the top edge. The round over bits that I'm using are white side router bits, and as I mentioned, on the bottom we'll be using a 1/4 inch radius. With this large 1-inch radius round over bit, I find that it works out much better if you take it in a series of light passes rather than trying to do it all at once, especially in a handheld routing operation. And now we've got our top rounded over nice, we got a small round over on the bottom. Now we need to dish out the center of the seat area. Swivels for chairs are generally built a lot more heavy duty than your conventional Lazy Susan bearing. And that's of course to handle all the stresses of getting in and out of the stool or chair. But they don't spin real freely. And for what I want to do right now, I want my seat to spin freely so we can contour the bottom. So I've got a Lazy Susan bearing, and I'm going to mount that up on a piece of scrap stock and to the undersurface of our seat. And that will allow me to set it up here on the workbench and have it spin freely while we shape the seat a little bit with an angle grinder. Now the reason why I want this to spin somewhat freely, I'll be taking this grinder and I'll be grinding away in the center. I want to hollow it out about, a 1/4 inch, maybe even as much as 3/8 of an inch, and create a dish shape in this area. Now when I'm working the grinder, if I angle the grinder just right, that will allow the seat to rotate as I'm grinding along like so. Now this type of grinder has an adjustable dust hood on it. It's made by Festool. It's got vacuum built in, and it uses sanding pads that are held onto the bottom with hook and loop. And it should work out real good to hollow this out. Again, this is just an alternative way of doing it from doing it on the lathe. It takes a little bit of practice to figure out how to angle the grinder so that you get the seat to spin, but not let it spin too fast or too slow. But just work back and forth from the center coming out, hollowing out that center portion. Now with most of the roughing out of the way, I'll switch over to my random orbit sander, which by the way you could use for this entire process. It'll only take a little longer, but I'll go through and finish sand everything up. Now with our seat formed to shape, what we want to do is prepare for the mounting of our swivel. Now this is our frame top, and as you can tell, we've already got the edge banding on, and I've sanded that up nice and flush, and I've marked my hole locations. Now on the frame top, we're going to need not only the 4 mounting screw hole locations, but we're also going to need an access hole in this area. And I'll be putting in about a 1.5 inch diameter access hole. And what that'll allow us to do is reach up from the bottom to put a screw through here into the bottom surface of our seat area. So I'll go through and drill my pilot holes for the mounting screws, which are number 12 by 3/4 inch long sheet metal screws. And then in this area we'll put in an 1.5 inch diameter access hole. Laying out the locations for these mounting holes, you'll just have to center up the swivel relative to the outside diameter of both the frame top and the seat bottom. And then for your clearance hole here, rotate the 2 pieces so they're 45 degrees apart from each other, and then just mark an area where you want to have that access hole. Well, this is what our hoop looks like at this stage. It's about 7/8 of an inch thick based on the number of plies that I've added. And now what I'll do is take it over to the belt sander and just start working this surface down until I got a nice, flat, smooth band all the way around. Now where the last band terminated, of course you've got an abrupt ending there. So what we'll do is we'll just taper that in by sanding away that material. As you can see right now, I've got my frame all assembled with some band clamps, and I've got my footrest hoop sitting on the legs. The legs are tapered, so it'll only come down so far. I've taken my square, which has a scale on it, and I've very carefully set it so that the hoop is parallel to the bottom. Now what I want to do is make a layout mark along the inside edge of the hoop where it bumps up with these legs. Because what we need to do is notch away some of this material right here to allow the hoop to come down the distance equal to its thickness. So in my case, it's 3/4 of an inch thick. So what I need to do is draw a line from the inside edge of the hoop coming down on the side of the leg. And I'll draw that line down 3/4 of an inch and then carry it straight across out to this surface on the leg. Then what we'll have to do is carefully carve, rasp, and fit the outside shape of that leg in that notch area to accommodate the inside shape of the hoop. Right now we're looking at the end of one of the legs, and what I've done is I've very carefully just positioned my hoop on the end of it like so, and then made a pencil mark. And that'll kind of give me a guide as I create the notch at the other end of the leg as to what shape that I'm looking for. Remember, we need that notch area to fit the inside contour of our hoop. Now this is that line that we drew at the square, which would be flush to the inside edge of the hoop, and then I've just carried that across to the other side as so. Now this bottom area, we're actually going to start out at the bandsaw to create the bottom of that notched area. Then the rest of it we'll shape out with some chisels. This is that notch that we're trying to create. This is the area that we just cut on the bandsaw. Then most of this area was cut away with a chisel and then rounded over ever so slightly with a coarse file. And that, of course, rounding is to conform to the internal diameter of our hoop. Now I'm just using a basic 1/2-inch bench chisel, and I'm just very slowly and carefully whittling away this material. This white oak that I have is very curly in grain. And the grain is running every direction possible, so I'm being very, very careful with my cuts. Take your time to get that hoop to fit up against the leg real nice. It just adds a nice touch to your overall finished piece. Once that's done, get everything back together, check everything for fit and so forth, and then we're ready for our final step with making the stool. And that's a combination of both finishing and assembly. Now these web frames, or these small braces inside here, will be stained black. So we really kind of want to do that before we do any further assembly or finishing operations. So I'll take it all apart. I'll get all of my edges softened up nice because they're rather sharp at this point, and that's really just not very comfortable. So we'll soften up the edges, do all our finished sanding, and then start with the staining and assembly. Now our first step is to stain our leg braces black. I'm using water-based stains and dyes in this project, so I've already gone through, wet everything, and then done a finish sanding on it. And that, of course, raised the grain, and then I sanded off the grain nibs. So now we'll get the stain on these pieces, and then we can move on. Now this particular water-based stain can be put on almost as if it were a paint. You can just brush it on and let it dry, or you can brush it on, let it soak in a little bit, and then wipe off the excess. Either way, we'll get a nice heavy coat on there because we do want these to look black. And we'll just use a light touch to wipe off the excess. And now we can go about starting our assembly. Now the first thing we'll do is get 2 legs with 2 braces put together, and then the other 2 legs with 2 braces will also be joined together at the spider. Now we want to make sure that we're flush all along this top edge. So adjust your parts up and down as needed, and that should do it. We'll just apply some light clamping pressure, let the glue take hold, and then we can move on. Now that the glue's had a chance to set up a little bit on these other pieces, we'll bring the other 2 legs together. And we'll just throw a couple clamps on here to help hold that tight while the glue takes hold. What I'm doing now is I've got my frame top upside down on the workbench, and then the frame sitting on top of that. And I've traced around where each of my 4 legs meet up with that frame top. And we're going to, of course, need to attach these 2 pieces together. So what I'm going to do, I'm going to drill a pilot hole from this side through to the other side, roughly in about the center of each of those 4 leg positions. Then from the top side, what we're going to do is install the Miller dowel system to hold our frame top onto the legs. Now, of course, you could use a wide variety of fasteners in this case. You could use screws, pocket hole screws coming from the leg into this frame top, perhaps even small biscuits in there. There's just a wide variety of different techniques, but I want to use the Miller dowel system. Now, that does utilize a special step drill bit, and what we'll be doing is drilling from the top side down through here and into the legs. So that's why I want to transfer the hole location from this side to the other side, so that I know where to drill those holes. I'm not worried about the exact position of these holes, just trying to get it roughly in the center of where that leg meets up. Now what we'll do is we'll glue our legs onto the frame top, and we'll let that glue set up a little bit before we go through and install the Miller dowels. Now you'll notice that the access hole that allows us to attach our swivel to the underside of our seat is in between 2 of the legs. We do need access to that location. Now that the glue's had a chance to set up a bit, we can drill our pilot holes for our Miller dowels. We'll get some glue spread around on our dowel and then drive it into the opening. Now I'll let that glue set up a bit there, and then I'll just take my flush trim saw and cut off the excess dowel. Now if you didn't get a real nice fit on these notches for your hoop, you may want to use an epoxy glue there. And that'll have a little bit better gap filling ability than either yellow or even polyurethane glue. And slide it down till it seats. To fasten the top onto the frame, we use the large Miller dowels. To lock the hoop in, we'll use their small size, and then that way it won't stick out through the back side. And again, we'll be using their special drill bit, and I'm just going to centrally locate the dowel left to right along the leg and top to bottom along the hoop. Now I will do my best to drill perfectly square or straight in. And once again, apply some glue and drive the dowel in. Then we'll cut them off flush and sand it up nice. To color the oak and to really pop the grain, I'm using a water-based aniline dye. The color that I'm using is called medium reddish brown. And I just mixed up a few ounces of it, and I'm going to spray it on with my HVLP spray gun, and I'll get a nice wet coat on there. Once it soaks in for a few moments, then I'll take a dry rag, wipe off the excess. And because this is oak and it has a lot of those pores in it, the aniline dye might try to weep out of those pores as time goes on. So I'll continue to wipe it down until it seems to be fairly dry and I'm not getting any more of that weeping. Then for the top coat, I'm going to spray on about 3 or 4 coats of a waterborne varnish. It's an Oxford brand product, and it's proven to be quite nice to work with, very low odor, and overall it gives you a real nice look on the finished piece. Now I know that if I don't put some form of foot on the bottom of these legs, eventually it's going to start splitting apart on me. So I'm just going to drill some pilot holes, in this case about 1/16 of an inch. And then I'm going to install these small metal feet. And of course they've got a nail on the end of them, but if we just drive that nail in without the pilot hole, there's a good chance we'll split the leg. I've already attached the swivel to the frame top, and now we can attach the seat to the swivel. Well, that should complete construction of our shop stool, also known as the director's chair. Got our swivel top. It's at the appropriate height for working on my workbench. It looks great, and it's pretty easy to build. I'm Chris DeHut for Woodworking at Home. Thanks for watching.